Today we're going to be talking about segments. Now, segments are sections of a line between 2 points. Segments have properties, but the most important property to understand is that a segment has a start point and an end point. For example, we have a segment from A to D on this truss, and it is bisected by another segment called C to E. Now, we'll often find that we'll be asked to find the length of these segments. Two segments can be added together so that the length of the new segment is the sum of the lengths of the old segments. So if I added segment A to D, A to B, B to C, and C to D, all of these being segments, then I would get the total length from A to D. Now, we want to talk about distance. The distance is the length between 2 points and is always positive. So a distance is how far apart two geometric objects are. Now remember, we have a point, let's say point A to point D, and that point has xy coordinates. So we could find the distance using the distance formula. Now, two segments that have the same length are called congruent. Now, that would mean from A to B is the same length of C to D and B to C, then all of these lengths are congruent, meaning that they have the same length. If I am looking at length A to F, then, and I wanted to know what the midpoint E was, that is basically half of the total distance. So a point on a line segment that divides the segment into two congruent segments is the midpoint. We talked about bisectors. So a line is a bisected segment that, for example, in this one, C to E, is a line segment or ray that passes through the midpoint of another line. So the line A to E is bisected by a line that you would say from C to E, because C to E goes through the midpoint of A to F. All right, now let's take a look at the ruler postulate. The ruler postulate says, using a ruler to find the distance between 2 points, the distance will be the absolute value of the difference between the numbers on the ruler. So I have 3 and 8. So if I subtract 3 and 8, I'm going to get 5. Now, here's the important point. It is the absolute. That means whether I subtract 3 minus 8, which would be a negative 5, the absolute value would make it a positive 5. All right, the coordinate is the number associated with the point. So if we're looking at length, we could say the coordinate is just 3. If we were in an xy plane, if the edge of the ruler was the 0 x plane or the 0 y plane, then we could say it's 3, 0 and 8, 0. Now, the other thing that we wanted to talk about that I mentioned before is the segment of the addition postulate. That means if I have a line segment from A to C, if I add the segment A to B and the segment B to C, I'm going to get the same as the length if I added the two together to get the segment A to C. Going on, this is kind of going back to our lines and graphing lines. The distance is on a grid. This says the distance is the absolute value between 2 points. For example, this line lies on the same plane in the y coordinate and at an elevation of, let's say, 4. So we have a distance from a negative 4 here to a negative 3 here. Now, when we subtract those two, we're going to get 7. Again, looking at it in the xy plane, you have the same x coordinates, but different y's. Okay, it goes on to say this formula here. We have the general distance formula to find the length between 2 points. We have x1, y1, x2, y2. We subtract those two. This should really look familiar, almost to find the slope of the line. So we have the square root of x1 minus x2 squared plus y1 minus y2 squared, and we take the square root. Be extremely careful when working with negative coordinates. That means when you have a negative, when you're squaring it, make sure it's in the parentheses when you use your calculator. We'll be working with the same formula when we look at the Pythagorean theorem. Now here's another important point, congruent segments. Here's the nomenclature, or what it looks like when somebody says these two lines are congruent. If it has the distance between this point here and this point here, shows that it's got a hashtag or a tag mark of 1, but the distance from here to here is represented by 2. that means neither one of these are the same length. Now, if they have equal hash marks, then you can say A to B and B to C has equal lengths. Now here's another important point. The midpoint postulate. Any line segment will have the exactly one midpoint. So that's the length of the line divided by 2. That would give you the half the length at where you define the midpoint. Do not assume the point is in the midpoint, as there are no tick marks representing where the points are congruent. Now a sector, bisector, is an array of segment that intersects at the midpoint, like I was showing you on this example over here. I've got A to F is bisected by C to E. What does this represent? It's a truss. This is something that the building construction people will see and have to deal with when calculating angles for trusses. But in this, when we're trying to find the formula of where this midpoint is, we can look at the XY coordinates. For example, if I said C to E is the same as this line segment here, I could find the midpoint of this line or this line by using this formula. So x2 equals x2 comma xy is said to, that means this point right here, this green coordinate here, is x1 plus x2, x1 being -5 and +3 divided by 2, comma, y1, 6, plus the y2, 2 divided by 2. Okay? Now, you'll be using the midpoint formula and the distance formula when we start working with the triangle relationships. All right, that's it for this video.